Okay, good day everyone and welcome. I hope you're doing well. Please note that the class is being recorded. I also hope you had a great week. Today's lesson will be a continuation of where we left off. So please make sure you have your textbook next to you as well as your calculator so that we can be able to proceed smoothly without having challenges. So I'm going to be sharing my screen and then from there we're gonna start with the lesson. Okay, here's my screen. With just a quick confirmation from all of you who are in the class, please just confirm to me that you can see my screen and I am currently audible enough.
Yes, sir, we can see.
Okay, thank you very much. Okay, let's start with our lesson. Our lesson is lesson 6. It's basic mathematics concept. As I can see here, also we still have introduction. So this is our new lesson which we are currently on, which is chapter 2 on our textbook. So I'm gonna start by doing a quick recap on everything that we covered previously, including the other weeks before, which is our first week, because some of the concepts that we covered there are still going to repeat under this lesson. So previously under lesson 5, we covered what we call the orders of operation, which is the Bodmer's rule. And then we also cover why it is important, especially in the media industry, to be able to calculate average. And also if you are able to it says that number 3, that can you think of a real life scenario where you might have to work out any missing figure. So these are the questions that are related to everything that we covered from the previous lesson. So we did cover the operations, we did cover uh, okay guys, I'm just gonna mute you. Let's start with this one. Okay guys, this is the reason behind me muting you, to avoid such background disruption, especially during the class. So what I'm gonna do is that I'm gonna mute you and I'm only gonna give you a mic during the question and answers, and after that I'm gonna close it back again. Okay, I believe all your mic are muted currently, so we're gonna be using the chat section as well as the raising of a hand in order for us to actually get to to see each other so that I can be able to track if there is someone who raised a hand. I'm gonna open my other device and make sure that it's also on so that I can see those who raise a hand, those who have got questions. So I'm currently joining on the other device and I'm currently in. So yes, I believe we can move forward. So let's move forward with our lesson before I start that. So previously under lesson number 1, we did cover the revision of numbers where we have got whole numbers, where whole numbers start from 1 up to infinity. And whole numbers do not have negatives and do not go backwards in terms of having negatives, so they are only positive numbers. And we also talk about the prime numbers. Prime numbers, these are numbers that can only be divided by 1 and itself gives a whole number answer. So we have got numbers such as 1, 2, 3, 5, 7, 11, 13, 17, and 19. So these we refer them as what we call prime numbers. So we're gonna be talking a lot about prime numbers. So make sure that you remember this or memorize them for this lesson and later on study them to understand them. And then we also have got even numbers, which we covered as part of our number system, where under even numbers, these are all numbers that are multiple of 2 and they are also divisible by 2. So meaning that that number you have to be able to divide it by 2, or when you multiply it by 2, it also gives you another number that is divisible by 2. And such type of number, we all have them in under whole numbers as 2, 4, 6, 8, 10, going upwards up to infinity. And then we also have got the odd numbers, where the odd numbers are those kind of numbers that are not divisible by 2 and they are given as 1, 3, 5, 7, 9, 11, 21, going upwards up to infinity. So normally they always end with a 1, 3, 5, 7, or 9, meaning that if you found a number that ends with a 1, 3, 5, 7, or 9, you'll have to understand that that number is actually what we call an odd number. It's not an even number. And even numbers normally ends with 0, 2, 4, 6, and 8. So remember on our 10 digit system, we've got numbers counting from 0 to 9. And therefore, only half of those number will fall within even numbers and half of those number will fall within the odd numbers. Where under odd numbers, we have 1, 3, 5, 1, 3, 5, 7, 9. On even numbers, we've got 0, 2, 4, 6, 8. So we're going to be using this to apply on today's lesson, which it's going to be based on the fractions. But before we start with the fraction, I want us to start by revising what we covered previously. So I'm gonna come to you guys. We have got the following equation, which says that 4 plus 5 multiplied by 2 is equals to, you are given two options, where you have got option A, which is equals to 9 times 2, which is going to be equals to 18. That is the first explanation of the answer that is missing there. Or the second option, which is B, which is going to be 4 plus 10, where we are going to say that based on the BODMAS rule under number A, we're saying that we're gonna go first by start by adding 4 plus 5 giving us 9, then multiply by 2 giving us 18. And the second option is saying no, we start by saying 5 multiplied by 2, then say plus 4, which is gonna give us 14. So from you guys with the raise of a hand, let's see who can actually get to answer this question for us. So I'm just gonna pick up exactly like what I was doing. So I'm just gonna do random pickups. So let's start with Sandy Sile. Can you please give us the answer for this? I've allowed you the mic. You can unmute and tell us which option gives the correct answer for 4 plus 5 multiplied by 2.
So option B.
Option B.
Yeah.
And how did you get to? Can you give us the right calculations?
So the BODMAS rule says you have to multiply before you add. So You have to multiply 5 by 2 and then add 4 to get 14.
Okay, 100%. So everyone managed to get that right. So that's the BODMAS rule. So multiplication before addition. So therefore we start by doing the multiplication of 5 times 2 giving us 10. Then we add the 4. So we are following the BODMAS rule. So there is no brackets, no orders, no division, no subtraction, just only multiplication and subtraction. And then we're gonna move to the second question, which says that in brackets 8 divided by 2 plus 5 multiplied by 3 minus in brackets minus 2 in brackets 2 to the power of 2 close brackets equals 2. So this one I'll be giving it to Sima. Can you please assist us in this one? Which BODMAS rule are you going to apply and how are you going to get and also give us the right answer for this? Sima, your mic is available. Just unmute and do the calculation and also give us the answer.
Excuse me, sir. I'm actually looking for a parking. Can I skip this one? I've just been listening. I'm stuck somewhere looking for a parking.
No, not a problem. Which means that we're gonna now move to Amukelani.
Okay, thank you.
You are next in line. Amukelani. Amukelani Banda. Just a moment. Okay, now you have got the mic. You can unmute. Amukelani. Okay, I see we can't get hold of Amukelani. Maybe the Teams meeting is just running. The phone is somewhere or the device is somewhere else. Ipeling, can you please assist us? Ipeling, Ipeling or Ipeling M. Can you please assist us with the second equation, which says open brackets 8 divided by 2 close brackets plus 5 multiplied by 3 minus 2 open brackets to the 2 to the power of 2 close brackets is equals to. Can you please assist us with the solution for this equation? Ipeling or repealing? Okay, I see we are not being able to get a response from the other student. So I'm just gonna skip this one to Sandisile. Sandisile, you can unmute.
Sure, sir. Okay, with this one, sir, I think it's best if we start with the brackets first. So I would, from my side, I would start with the 2 into 2 to the exponent 2 and try to solve that, of which will give me 2 into 4 because 2 to the power 2 equals to 4. So it's going to be 2 into 4. And then 2 into 4, so it's negative 2 multiplied by 4, which will give me negative 4. And then I'll jump back to the other bracket, which is 8 divided by 2, which will also give me 4. So now the, the equation is 4 plus 5 times 3 minus 4, right?
Okay, I just want to be typing what you're saying so that it's much easier. You're saying your equation will be, you said you're gonna say 8 divided by 4 giving you 4. So we still have plus 5, we still have got times 3, we still have got minus 2, and you said you're gonna be having how much? 4 here. And then what's the next step?
Brackets again, I'm gonna have 4 plus 5 times. Okay, we could just go 4 plus 15 minus 8.
Okay, so meaning that now we're gonna be having on the second step 4 plus 15 minus 8.
Yeah.
And then from there,
And then the final answer will be 19 minus 8 is 11.
19, so we're going to have 19 minus 8, and the last answer is 11. So this will actually be the solution for this equation. So you're 100% right. So what actually happened is that under this kind of equation, what we do is that since we're following the BODMAS rule, we start by everything that have got a bracket. So everything that is inside the brackets, that's what we start with. So if we take a look in terms of following the BODMAS rule, so we've got everything that is inside the brackets. So after looking in terms of the bracket, then we take a look as well with everything that is have got any other, then we repeat the BODMAS rule again. Are the brackets inside brackets? If there are none, therefore we solve for the second part, which is orders. So since we've got brackets, these two brackets will have to solve them simultaneously, because they are both under, we both to have what brackets on the left and to the right. So what we actually do is that we start by performing the one on the left and moving towards the right one on the right. So when we perform everything within the first bracket, it's going to be 8 divided by 4, cancelling everything that is inside the bracket. Since we already done that, it's going to give us 4, which is 8 divided by 2, giving us 4. And then on the second bracket, while we do it simultaneously, it's going to say 2 to the power of 2, which is equal to 4. But since now we only have solved what is inside the bracket, we still actually have to multiply this with the number that is outside the bracket. So that's why I managed to do this, to say that because this one I've got orders, we're gonna first solve the orders and then later on clear the brackets again, so that we can actually get to have an accurate calculation or following the right step, so that we don't get to do a miscalculation. So therefore we're gonna have 4 then multiply by 2, giving us actually 8. So therefore now once we have got here where it's going to change to 8, so you can actually go and just say this is going to end up giving me 8. So that's simultaneous calculation of everything within the brackets and cancelling the brackets. And then later on you go and say we have removed the brackets, and the brackets also had orders inside them, so meaning that the orders were removed simultaneously while we're removing the brackets. And then we move towards the to check whether we have got division, multiplication. So since we don't have division, we've got multiplication that comes before addition and subtraction, so we start there. So we're gonna go and say 5 multiplied by 3, and then it's gonna give us 15. So therefore our next step is 4 plus 15 minus 18. And since now we are left with addition and subtraction, what actually happened is that we mentioned that the two hold the same weight, the addition and subtraction, meaning that we're going to start from the left to the right, because they both hold the same weight. So meaning that we're going to start by saying 4 plus 15, which is from the left to the right, this giving us 19, then minus 8 giving us 11. And then now we are working with division with a line, where we've got an equation on top as a numerator and an equation as a denominator. So under this question, it says that 2 multiplied by negative 5 plus 16 divided by 8 divide by, all of this is divided by negative 12 multiplied by negative 2 minus 26. It equals 2. So the person that I haven't asked yet, Neo, your turn. Can you please assist us in how we're gonna solve this applying the division line and the BODMAS rule? Neo? Okay, we can't find Neo. Okay, I deleted everything here, so I can't find most of the things that I need. So I'll just re-put this back. Okay, here we are. So let's start. Nia it's not around. So Amukelani, are you back? Can you help us? Okay, there is a text coming from Nia. Okay, some are driving, so they are attending to the class while driving. So guys, I won't advise that you attend a class while driving. It's a very, very, very dangerous thing to actually do, because you have to concentrate, pay attention to what I'm saying, also look in the screen of what I'm saying, and one split of a second, it's actually what is needed for just for a distraction that to happen and an accident to happen. So please, guys, just plan around in terms of class when we have online class, so that you plan and make sure that you are in a secured place and you are not actually driving. If you are driving, just find a nice place, park aside, attend the class. Once you're done, resume the journey or resume the work. That is a very, very, very not a good thing to actually do, unless you're only applying the audio within only applying the audio, where you just only get to listen to what I'm saying, which you could be visualizing some of those things, because we get to learn in different ways. So in absence of that, let's move to, okay, it seems Sima, are you back now? Can you assist us? Sima, Sima, are you back? Okay, Sima is not around. So what I'm gonna do is that, oops. So what I'm gonna do is that I'm gonna solve this one on all of your behalf, and you just get to pay attention. So when you're solving numbers with when you're solving numbers with a division line, so we refer them as a division line because now the numerator and the denominator are no longer the numerator and the denominator are no longer under what we call a standard fraction. So you also actually have now an equation. So we're gonna refer them as division line. So what we're gonna do is that under this kind of equation, we start with what is on top, which is the numerator, and then we move forward downwards to the denominator. And what we actually do is that we perform this simultaneously using the BODMAS rule. So under this one, we're gonna start with the numerator and say, let's follow our BODMAS rule and see what we have in terms of our BODMAS rule. So do we have any brackets? We don't have. Do we have any off or orders? We don't have. Then do we have division and multiplication? We look at those together at the same times. So yes, we do have division and multiplication at the same time. So we're gonna perform them simultaneously, and therefore what we do is that we start from the left to the right. So meaning that we're gonna start by saying 2 multiplied by -5, so that will give us -10, and then we said plus, and when we perform again simultaneously, 16 divided by 8 giving us 2. And then we're gonna move downwards to say that now under the downward, let's therefore apply again the BODMAS rule. So we don't have brackets, we don't have off or orders. We do have division, and we don't have we do have multiplication but no division. And then we do also have subtraction but no addition. So based on the BODMAS rule, we're going to start with the multiplication, which is -12 multiplied by -2, which gives us -24, positive 24, which is going to give us a positive. So a negative multiplied by a negative gives us a positive, therefore -26. So that is the first step that we're going to have in terms of our calculation. And then from there, what we're gonna do is that we're gonna go and insert another equation. So I'm just still waiting for my equation. so which is gonna still be within the fraction. So what we do then from here, we're gonna go and say negative 10 plus 12 giving us minus 8, and then we move forward to 24 minus 26, uh, positive 24 minus 26. This will give us a negative 2, and then this gives us our final answer as negative 8 divided by negative 2. Based on the rules of multiplication and division, we both know that if you are dividing a negative with a negative, you get a positive final answer. So therefore, our final answer for this equation becomes 4. So is there anyone who have got any question on the BODMAS rule? Anyone? Anyone with a question on the BODMAS rule? So I assume that we don't have any question. I see no raise of hands. So we're gonna move forward. So this is just a recap of everything that we covered, and make sure that your memory is back and you understand everything that we covered, or your memory brings back everything that we covered. So now I'm gonna moving up to what we call a full slideshow so that we can start with our lesson. So our lesson of today is continuing, it's lesson 6. So the textbook is still finance in media. For this lesson, we're gonna be covering page 74 to 83, and we're gonna be dealing with what we call fractions. So we're gonna work with fraction, and we're gonna also work with simplifying fraction and the basic calculations with fraction, and identifying equivalent fraction where both this fraction have got the same value at the end. So this is the lesson for today. And the learning outcome for this lesson is that by the end of the lesson, you should be able to appreciate the application and relevance of fraction in everyday situation and transaction, and see this mathematical construction as a useful tool and not just as a subject you must pass, and understand the purpose of a fraction and know how to simplify a fraction, and then later on learn simple tips for working with fraction and identifying equivalent fraction. So normally we use fraction on our daily basis. For example, we'll start with an example of a pizza. So normally when you buy a pizza, you know that a pizza comes with with a minimum of 4 slices to a maximum of 8 slices, depending on the size of the pizza. So if you are having an extra large pizza, you might find that it's gonna contain somewhere between 12 to 16 slices, and normally, or bigger slice which are equivalent to 8 slice. And if you are actually there are 3 of you and you have to divide 8 slice, so you need to be able to actually get to use a fraction to say that we are actually 3 and we've got 8 slice of pizza. So how do we actually get to divide that? So we actually perform fraction on a daily basis, but some of the times we are not aware of that. So, but in terms of the real world of finance where we get to work in, we perform fraction in numbers of ways. The first example that I'm going to give is actually when we perform what we call depreciation. A depreciation is to say that an asset is losing value, and this is the value that it's losing on a daily basis or on a monthly basis or yearly basis. So when we perform those kind of activities, we get to calculate them to say that we receive the assets now in March, and this assets is worth 20,000, or this equipment is worth 20,000. Based on the SARS application or the law, this asset actually loses value by 20% each and every year. So you will going to calculate 20% of that asset on a monthly on each and every year to say that how much is 20% over the year. And then once you get that for that 20% over the year, to say that it's losing 20% over the year, you still have to apply that on a monthly basis, meaning that you are going to split that into a fraction of a monthly base to say that for each month, which is going to be 1 out of 12, this is how much it's actually losing value for. So this is where we also get to apply fraction. And you can also apply fraction where you're actually getting to split a bill, where you're also getting to calculate the portion of money that have to be paid between both the owner of the company. So if you founded a company with the other person, which is gonna be your co-founder of the company, so what actually happens is that you guys are gonna contribute money towards the business as a capital. So that capital money will be invested within the business, and each of you will invest different amount or equal amount. If you deposited equal amount or contributed equal amount, meaning that you're gonna have as well equal share within the business. If the business made a profit of 100,000, you're gonna split it 50-50. But if you don't share actually the same profit, to say that we are two but the profit now it's 150, the other one actually went and deposited 70,000, you contributed 30,000. So meaning that we are going to split the profit based on the ratio of that, which is going to be a fraction. When we split for the other one who contributed 30, we're gonna say that is 30 out of 100, because in total the all amount that is contributed is 100,000. So that will give us a share in terms of the profit. And the one that contributed 70, we're gonna say 70 out of 100, where we get to add all the amount to be equal to 100, which is your contribution. So his share should be equaling to 70 out of 100. So that's how you're gonna split the profit. So in the simplest terms, it's just gonna be 70% and 30%, and then you're gonna calculate that based on the profit that have been generated. So those are the calculation that you perform on a daily basis that involve fraction. And then in terms of fraction, we've got what we call proper fraction, improper fraction, as well as mixed fraction. So the first type of fraction that we normally have is what we call a proper fraction. So a proper fraction, when it gets to be calculated using a scientific calculator, we actually get a result that is in decimal and that is actually recurring. Or if it's not recurring, that number have to be a rational number. If you remember what to refer the rational number is the number that either have recurring decimal or it's a whole number. So we call that a rational number. So meaning that if we said 4 divided by 4, you're gonna get 4, so that's a rational number, and we also refer that as a proper fraction. Another proper fraction example is given here. When you cut a cake, we normally cut it in equal slice and share it in equal slice, so we call it a proper fraction. And then another proper fraction in terms of a fraction, when this is, let's assume that this is a pie. So a pie, if you divide it into 4 pieces and remove 1, so meaning that you'll be left with 3 out of 4, meaning that we also refer that as a proper fraction, meaning that the numerator is smaller than the denominator. So that's what we call a proper fraction. And then when we refer to this as an improper fraction, an improper fraction is a mixture of both. Sorry, an improper fraction is when you have got more people requiring to share a lesser amount or object. For example, I still use a pizza to say that if you have a pizza that have 8 slices and you're actually 10, there are 10 of you, and the slices are 8. So that's what we call an improper fraction. So sometimes an improper fraction can be simplified to a mixed fraction. So these two, they go both ways. So one can be splitted into another one. So most of the time we found an improper fraction as first as a mixed fraction where the numerator is bigger than the denominator. So, and when we calculate this, it's gonna say 22 divided by 5, it's gonna give us 4 and 4 to 2n over 5. So this will be what we call the mixed fraction. And to return the mixed fraction back in proper fraction to a mixed fraction, this is what we actually get to do. So this is your improper fraction and this is your mixed fraction. So we're gonna play around with these two. So this one is an improper. So if you say 22 divided by 5, it's gonna give you 4 to 2 out of 5, which is the mixed fraction. So the reason we refer this as a mixed fraction, it contains a whole number as well as a fraction at the end. And for us to reverse this to an improper fraction, we use a method that we simplify it as u being mad, or just saying mad. So what we do is that you take your denominator, you multiply it with your what we call you multiply it with the whole number, giving you 5 times 4, giving you 20. And then later on, you add it with your numerator, giving you 22. So therefore, you're going to have a improper fraction of 22 over 5, which it can also be reversed back again to a mixed fraction. So that's related to improper and mixed fraction. And then I already explained this within this, so we're gonna skip this part. And then simplifying fraction. So before we simplify fraction, let me see from your textbook if there is something that we can actually get to play around first with. So on your textbook, so today's lesson, as I did mention, that we are working with fraction. So okay, my laptop seems to be a bit slow. I don't understand why. So here is another type of a fraction. So here they're showing you a fraction that we've got a numerator and a denominator from your textbook, and this can be expressed as an a over b, and it's also known as a rational number. So here we've got an activity which says that determine what fraction of the following diagram is shaded to. So what we actually get to do under this diagram is that you first have to count everything that is available within this diagram. And then it says that determine what fraction of the following diagram is shaded. So we have to calculate all the numbers that are shaded out of this whole diagram. So meaning that we're gonna say we have got 1, 2, 3, 4, 5, 6, just like that up to until the end. So for me, I use a simple method 1 times 2, 3, and then I said 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 times 3. So therefore, that's gonna give me 27. So meaning that we have got 27 blocks here. And these 27 blocks are all equal. So I use that mathematic, which is used under what we call the mental arithmetic. If you still mental arithmetic, which says we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and we've got 1 squared giving us 1, 2 squared giving us 4, so that's 1, 2, 3, 4 blocks. So that mental arithmetic table is there to assist us in situations like this, where we get to also work with fraction to say that how many blocks are here within, so that we can identify the numbers of blocks that are shaded within this diagram. So what we do, we count the number of blocks from left to right. That will give us the first number in terms of the mental arithmetic table. That is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we count the one going downwards. So then 1, 2, 3. So which is going to have 3 multiplied by 9. Therefore, we use our mental arithmetic table to say what is 3 multiplied by 9, which have to be stuck in our head. So that is going to be 27. Then from there we calculate the number of blocks that are not shaded, that are shaded. So if we know that the number of blocks that are shaded are so many compared to the ones that are not shaded, so what we actually do is that we use a different method called the reverse method. We only calculate the smaller one and subtract them from the total to get the difference in between the numbers. So instead of me calculating this because there are so many, what we do is that we're going to calculate this and say 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 blocks shaded, and therefore the total number of these blocks are actually 27. So meaning that if 8 are not shaded, the remaining are the ones that are shaded. So we're going to go and say 27 minus 8, that's gonna give us 19. So 19 blocks are actually gonna be shaded because already 8 are not shaded. So meaning that the fraction for blocks that are shaded to the total diagram is gonna be 19 out of 27. And for the ones that are actually shaded, not shaded, to the total diagram, that will be 8 out of 27. So this is an example that was given in your textbook or activity, so you can perform that. And then we also have got what we call equivalent fractions. So also have got what we call equivalent fraction. So with equivalent fraction, before I can explain that, just give me a second just to close the door. There is some noise that is currently disturbing me. Thank you for that. So in terms of equivalent fraction, so equivalent fraction, these are the type of fraction where they have the same value at the end when they are calculated. Their value actually brings the same, even though the numerator and the denominator are totally different amounts, but they are still having the same value with another what similar fraction. For example, we've got the shaded part. We've got these four different blocks or different rectangles. The first one is divided into two pieces, so and one is shaded, so the fraction for this one will be 1 out of 2. So if we were to calculate the shaded part compared to the whole object, which is the rectangle, so meaning that we've got 1 out of 2, which is also the same as even if this rectangle was divided into 4, meaning that and 2 were shaded, so therefore we're gonna have 2 out of 4, and 2 out of 4 will still give us the same figure as our 1 out of 2. So if we say 2 divided by 4, that's 0, 0.5. 1 divided by 2, that's still 0, 0.5. So we refer this kind of fraction as equivalent fraction. So they can go forward and further and further and further up until infinity, but as long as they still give you 0, 0.5, we're gonna refer them as what we call equivalent fraction. So not only those that are what we call or not only those that are giving you 0, 0.5, we're gonna only refer them as equivalent. We still have got 1 out of 3, which is still 0, 0.33, and then we still have got another fraction that also give you 0, 0.33, which is still gonna be equivalent to 1 out of 3. So there are number of equivalent fraction that when you get to see them, most of the time they will be falling within what we call the same number system, which is either odd or even numbers. So that's how we can get to quickly identify them as either whether these are equivalent fraction, because they're gonna give us the same value at the end of the day. So this is an example of some of those equivalent fraction to say that based on the following, we've got 2 out of 5. 2 out of 5 is the same as 8 out of 20. So they are both equivalent because they will give you the same value. Normally, how to find those kind of equivalent fraction, it's when you are able to multiply both the denominator and the numerator by the same value. Whatever value that you'll get later on will be what we call an equivalent fraction of the previous one that you just did. We have got 3 out of 5, so if you multiply both of these by 6, you're gonna get 18 out of 30, which is still equivalent to 3 out of 6. So if you enter this into a calculator, you're gonna get the same value. So here it says that the fraction above have the same value because we are multiplying both by 4 and also the denominator by 4, or the numerator by 3, or the denominator as well by -3. So all of this multiplication at the end they give you 1, meaning that it's still gonna have the same value as the previous one because of the numbers that are being used as a factor to actually simplify or to give you the equivalent fraction. So if you set 4 out of 4, it will still give you 1. -3 divided by -3, it will give you 1. But if you are trying to find an equivalent fraction and you go and say this multiplied by 4, this multiplied by -3, and you go and say 4 divided by -3, it won't give you 1, meaning that that fraction will no longer be equivalent to the same one. If you calculate it, you will not have the same value as that the one that you actually had. So if we go and say 2 times 4, that's going to be 8, and 5 times 3, that's going to be 15 out of 8. And if you say 15 out of 8, it's going to give you a totally different answer compared to 2 out of 5. So for you to have an equivalent fraction, both of those two fractions actually have to have the same factor within, which is of the same value from both the numerator and the denominator. So when simplifying a fraction, this is what we get to apply in terms of the rules of simplifying a fraction in order for us to get equivalent fractions. So what actually happens is that the first thing is the rule is that the even numbers are divisible by 2, meaning that you first look in terms of both the numerator and the denominator. Are the numerator and the denominator divisible by 2? If yes, they are divisible by 2, meaning that you can divide both the numerator and the denominator by 2, or multiply the numerator by 2 and the denominator by 2 to get an equivalent fraction, and then which is gonna be either bigger or smaller, because now we're simplifying. So when you simplify something, you try to make something that is very hard to understand or to calculate and make it a very small size so that it's easier to calculate. For example, if we've got 50 divided by 100, so we'll have to simplify that to smaller numbers that we can actually calculate, and it will give us value as soon as a fast value, or simplify the fraction to a smaller values. So the first thing that we do is that we check if both numbers are divisible by 2, then we're going to divide that by 2 and simplify that fraction using a common factor of 2. And then if the sum of the digits of the numbers is divisible by 3, so meaning that fraction, we're going to simplify it by dividing everything by 3, meaning that it's going to be simplified by the factor of 3. So we refer it as a factor because we're simplifying everything using that number, so we refer to that as factoring. And then a number that is divisible by 4 is the same as the number that is divisible by 2, because they fall within the same number system, which is the odd numbers. And same applies to all some of them that falls within the what we call odd numbers, where we've got 3 and we've got numbers that are multiples of 9 and multiple of 3s. So some of those numbers, they all fall within the odd numbers, and meaning that they will only be divisible by 3. So if both the denominator and numerator are within the multiplication of the 3s and the 9, that means that those both numbers can be divisible by 3, and therefore that fraction can be simplified by using 3. So it continued to say that a number is divisible by 4 if the number formed by is the last two digits. It says a number is divisible by 4 if the number formed by its last two digits is divisible by 4. So meaning that if this number, if you take it 7,242, the last digit is 2, which means that if the last digit is 2 and 2, it's also a multiplication, or it falls within the odd numbers within the fours, so meaning that this number can also be divisible by 4 because it's in a thousand value. But if it's just a single amount which is in the ones, so normally sometimes you find that it cannot be divisible by 4 even though it's an odd number. For example, 10, it's an odd number, but it cannot be divisible by 4 because it's gonna leave remainder, which is 2 out of 4, and therefore that 2 out of 4 is the same as 1 over 2. So we only get to say that the amount is divisible by and or simplified based when we say 7,000, when we say the 7,242 divided by 4. So you will see that this is gonna leave a remainder of 0.5. So therefore, meaning that we can only get to use 2 actually, because this amount will not leave a remainder. So therefore, the last digit is 2, which falls within the odd number. So therefore, we can actually divide this by 2 to say that 7,242 divided by 2. So meaning that the simplest of this number would be 3,621, 3,621. So if you take a look, we have got 1 here at the end, and 1 is not divisible by any number, either 3 or 2, meaning that that's the end, or that's the stop of the simplification of that particular number. And then where a number is divisible by 5, it ends with a 0 or a 5, meaning that we can simplify a fraction that have got both 0 on top and 5. That number must be ending with a 0. It must not be 0 equal to 0. So it has to be 5, a multiplication of 5, and either in tens or hundreds, and that hundred must not have, the final digit must be a 0. For example, 110, and then you also have got 115. So all those numbers can be divisible by 5, so meaning that we can simplify those by dividing them by 5. And then another number is divisible by 10 if it only ends with a 0. So here we've got an example of fraction that needs simplification, where we've got 11 out of 121. So what we do is that when we simplify, we look for a common factor between the two that we can do. So 11 normally doesn't have a common factor except itself, which is 11. And then 121, based on our arithmetic table, if we remember very well, is that it is calculated by 11 squared, or 11 times 11, meaning that therefore we can actually get to use 11 as a factor and factor out this equation and simplify it to say that 11 divided by 11, which is going to give us 1, and then 121 divided by 11, which is going to give us 11. So meaning that 11 divided by 121, it's equivalent to 1 over 11. So let's do that on a calculator. So 11 divided by 121 is equal to 0,09091, and 1 divided by 11 is still the same, give us the same answer. So that is what we call simplifying a fraction. And then again, we have got 100 divided by 300. So the common factors for these ones are so many, because these all numbers are in hundreds and their last digit is 000. So we can use 10 to divide, or if we don't use 10, we can use 10 and divide it and simplify it, and once we get another one, it will still be simplifiable. So we start by looking at the numbers themselves that are within the fraction to say that, can we use any of the number within this fraction, especially the numerator? So we take a look at the numerator. Can we use the numerator first as a factor to factor out and simplify this? If it's possible that the numerator can actually go into the denominator, divide the denominator, and without have recurring decimals, therefore that amount becomes a factor. Same example like the previous one, 100 out of 11. So 100 can actually be a factor, meaning that if I go and say 300 divided by 100, I'll just get a whole number instead of decimals. So meaning that 100 can actually be a factor for this equation and can be used to simplify this equation by saying 100 divided by 100 giving us 1, and 300 divided by 100 giving us 3. So meaning that this is equivalent to 1 over 3. And where both numerator and denominator do not fall within the prime numbers, where the prime numbers I did mention them 1, 2, 3, 5, 7, 9. So those are what we call your prime number. So if it doesn't fall within there, therefore we cannot actually get to have a what we call a common factor to use to actually get to simplify this. So under this one we have got 11. Let's try by taking a look at 11 first. So 11 cannot be used as a common factor, because if we divide this by 19 by 11, we're gonna get 1 comma something, which is gonna be also a recurring decimals. So therefore we cannot actually use that, or irrational decimals. So therefore we cannot apply 11 as a factor. Then now we look in terms of our prime factors. If we use any prime factor here, both numbers, even when divided by prime factor, will actually not equal to a whole number but recurring decimal, or irrational numbers where the decimal are not recurring. So meaning that we cannot simplify this equation of fraction. So therefore we leave it as it is, as 11 over 19. And then we take a look in this one. So this one, both the numerator and denominator are divisible by 5. So this fraction can be simplified to 1 over 26, where we get to divide everything first by the numerator. So we start by taking a look in the numerator. Can the numerator be the factor? Yes, it can be. 130 divided by 5 give us 26, which doesn't give a remaining decimal. So therefore 5 can actually be a factor. So therefore if you say 5 divided by 5, it will be 1, and then 130 divided by 5 giving us 26. So therefore the simplest fraction of 5 out of 30 is 1 over 26. Another example that I'll give is 4 out of 20. 4 out of 20. So with 4 out of 20, the first thing we start with 2, which is the first which is the first prime factor. So prime factor is 1, 2, 3, 5, 9, and 10 going upwards, based on all the numbers that are actually divisible by to another number. So those are the most common factors: 1, 2, 3, 5, and 7 is also one of them, and then 9. So those are what we call your prime factor. As I mentioned earlier on, that you have to remember this. So under this one, we're gonna go and say the first prime factor for this one. Let's start by looking in terms of 4. Can 4 be actually be a factor within this? So we're gonna go and say 20 divided by 4. So we're gonna go and say 20 divided by 4. So yes, it does gives us 5. So meaning that we can use 4 as a factor within here to simplify this to its best simplest form. Meaning that if I say 4 divided by 4, I'm gonna get 1 and then out of 5. So meaning that 4 out of 20 is equivalent to 1 out of 5. Then someone might go and say, what if I use 2? So if you go and use 2, you're gonna go and say, okay, if I say 4 divided by 2, I'll get 2. And if I say 20 divided by 2, it's gonna give me 10. So meaning that the first thing you're gonna get is 2 out of 10. And once you get 2 out of 10, 2 out of 10 can still be simplified because 2 can still go within all of these numbers. So meaning that you still simplify this further and say 2 divided by 2 giving you 1 and 10 divided by 2 giving you 5. So which still leads to 1 out of 5. So the best way to actually start a simplifying a fraction is to start by using the denominator first as a factor and see if it can actually go into the denominator and not leave any reminder. If it doesn't leave any reminder, we use it as a common factor to simplify all the fraction. So any question, guys? Any question? Any question? Okay, let me just do quickly this. Can I say by thumbs up that you are all excited? You don't have any question, we can move forward. Just thumbs up like this, and then I'll know that you are still safe and we can continue. Guys, are you still here? Hello? Okay, thank you very much. I thought maybe I was alone just talking to myself. So we did work with a fraction. So those are the type of information that we get to work around with in terms of simplifying fraction. So we first basically find what we referred as a common factor to make sure that the fraction is actually simplified to its simplest form. So simplest form meaning that it's easier to work with and understand, because if we get to say 1 out of 3, normally we already understand that 1 out of 3, because it's a commonly used simplest fraction, we know that it's 0.333. And then if you find 1 over 2, you know that this is actually 0.5. But if you find 80 over 160, you're not gonna quickly think that this is actually 0.5, because the number is very big. So you might have some time to actually simplify it and see what is its simplest form, so that I can actually get to see if I can actually get to find the answer as soon as possible, meaning that 80 if goes to 62 times and therefore itself 1 time, so that's one equivalent to 1 out of 2, meaning that this is the same as 0.5. The final answer is 0.5. So checking your textbook. So your textbook, they've shown this activity here to say that you have got 45 out of 75. So if you want to simplify this, we first start by looking into 45. So 45, can we actually divide 75 by 45 and give us what we call a right answer? So no, it cannot. So meaning that now we move towards what we call our prime factors. We've got 1 is already out. So we've got 2. Can 2 go into these numbers? Nope, it cannot go. So therefore we've got 3 as a what? Second factor, so prime factor. So since we have got 2 2 cannot go, and then we've got 3. Can 3 go into these numbers? Yes, it can go into these numbers. So you can start by simplifying by 3 this fraction and go and say 45 divided by 3 and then 75 divided by 3. So I just need a calculator. We're going to say 45 divided by 3. This will give us 15. And then once we have 15, we're going to say 75 divided by 3. That's going to give us 25. So now we have got 15 over 25. Since now we've got 15 over 25 as the first simplest fraction of that, but this is still divisible by another prime number, which is 5. So therefore, if we go and say 15, can we use 15 first as a prime from the simplest? No, we can't. It can't go and live without a remainder on 25. So therefore, let's look for this other one. We already skipped 1, we already skipped 2, we've already used 3, and 3 gave us 15 over 25. Now we move to 5 as a prime factor. So can 5 actually go into both of these without leaving a remainder? So therefore, yes. So therefore, we're going to go and say 15 divided by 15 divided by 15 divided by 5. So we're going to go and say 15 divided by 5. This will give us 3. And then we're going to go and say 25 divided by 5 as a second, therefore giving us 5. So meaning that the simplest fraction that we can get is actually 3 out of 5 for 45 over 75. So it's having the same value as 3 out of 5. So because we actually went and used 2 prime factors to get to 3 over 25. So what we actually do is that we can multiply those 2 factors that we use, those 2 prime common factors that we use to actually get to have the simplest factor that we can use. So if we say 3 multiplied by 5, that's close to 15. So meaning that under this equation, we can actually use 15 to actually get to 3 out of 5 as the fastest rate. So these are some of the tricks that we get to work with. So as you know that both this number are multiplication of 5. So the best multiplication of 5 that can go within this, it's actually 15, because 5 plus 5 plus 5, it's 15. So the best way to find that 15 is also to use this method. So we use a prime factor of 3 and we also use a prime factor of 5. So therefore the quickest way is to say 3 multiplied by 5 giving us 15. So if we go and say on our calculator 45 divided by 15, it's gonna give us 3, and we're going to say 75 divided by 15, it's gonna give us 5. So here it's explained in the following method to say that okay, they skip that part. So here they are showing you another way of simplifying to say that we can use cancelling to get a simplest form, to say that 32 divided by 48 if we have to get the simplest form. So you're gonna start by dividing this back to its simplest form. So you can either use 4 or and then you're gonna get to 4 out of 6, or you can actually use 32. If 32 cannot go, therefore you look, we start by using 2, and 2, after 2 we move to 3. Can 3 go in? If not, we skip 3 and we move to 5. If 3 cannot go in, we move there from that, just like that. So we simplify this until we get it back to the simplest form, which is just normally 2 digits or 2 whole numbers in a fraction. So that's what we call a simplification of a fraction. And then now we have got another method that we normally use. So this method, we use it to find what we call the lowest common factor, where we are now saying to say you have got 2 fractions and these fractions are being added together. So how are you going to actually add 2 fractions together that are not having the same denominator? So the method of adding fraction are that if both the denominator are the same when you're adding or subtracting, you just add or subtract the numerator. So if, for example, if we're saying 2 over 4 plus 3 over 4. So what we're saying is that if both the denominator are the same, then you add the what? The numerator, which is going to be 2 plus 3, giving you 5 over 4. And then if we are to subtract, so if we were to subtract, so what's gonna happen, you're just gonna say 2 divided by 4 minus 3 out of 4. Because they both share the same denominator, the rule of mathematics says that you just subtract the numerator, which is going to be 2 minus 3 over 4. And therefore you're gonna have what? Minus 1 over 4 as your final answer. So, but for us to actually get to calculate some of these, you find that when you're working with this scenario, sometimes you find that you have got 1 over 4 plus 2 over 3. And then you actually have to add this kind of fraction. So what we normally do is that we look for a common factor and simplify this fraction using what we call a common factor. So when we perform a common factor, we go and say what is the number that both of these can actually go into, or what is the number that can divide. First we look in terms of division. Can these two numbers be divided by the same amount? If not, therefore what is the number that these both numbers can actually go into, but that number have to be the first lowest number within the multiplication or the multiplication of both these numbers. So here we are trying to look in terms of the lowest common factor for 8 and 12. So what we basically do with this kind of method, so this method that we're performing here, it's a basic principle method. So it goes like this way. We go and say, okay, both numbers are within the odd numbers, sorry, the even numbers. So they're both divisible by 2. So let's use 2 until we actually get to reach to the common factor of both these numbers until the last digit is actually 1. So we're gonna go and say 88 divided by 2, that's gonna give us 4. So we have got to use the first one, we've got the first 2 which we used, and then 4 divided by 2 give us 2, so that's the second 2, and then 2 divided by 2, then it can give us 1. So the lowest common factors for this is 2 multiplied by 2 multiplied by 2. And then we move to the third one, to the second one, which is 12, to go and say that we have got 12 divided by 2 giving us 16. So we have used the first 2. And 6 can be still be divisible by 2, so therefore we've got 6 divided by 2 giving us 2, and giving us 3. And then 3 can no longer be divided by 2. So what is the next prime factor? It's actually 3. So we're gonna go and say for this to actually be there, for since we can no longer use 2, we're just gonna go and say 3 divided by 3, which is gonna give us 1. And therefore we put that we use 3 as a prime factor. So what happened now is that we identify the numbers in the second line that already appeared in the first line in case they are 2 times 2, and then we cross out the numbers that is repeating on the same level. So on the first one we use 2 and 2, we have got 2 and 2 which give us the second value, so we can cross one of those under any function to say that okay, based on this block 1 is repeating, so let's cross out 1. And then we go to the second block, we have got 2 times 2, so this common factor is also out, so we're gonna crash 1 out. And then under this block, is there any common factor repeating? So no, we only have 2 times 3, so meaning that we're left with 2 times 2 times 3 times 2 and times 3. So when we calculate all of this, it's gonna give us what we call 24. So 24 becomes the lowest common factor for this function. Meaning that when we are going to simplify these two, so meaning that we can simplify any function that contains 8 and 12 to 24. So please just give me a second just to clear my nose. Okay, I'm currently back. So as I was still explaining that this will become the lowest multiple factor. So to find how we managed to get to 24, so I'm gonna use you guys, I'm gonna show you another different method. So we're gonna go to an Excel file that I opened. So based on this Excel file, so we're looking for common factor for 8 and 12, lowest common factor. So as I did mention that a lowest common factor, we're actually looking for what we call the lowest common multiple of each number. So for example, to say 8, for the first one, we're going to say 8 times 8, 8 times 2. We're going to say equals to 2 times 8. This will give us 16. And then we're going to say equals to, it's a additional calculation of, so we're gonna get 24. So what we do is that we said on the first one, can both number have share the same common number within them? This is not yet the same common number. So you can move forward and calculate these and move forward and say, okay, 12 plus 12 again is gonna be 36. So the following number is 36, and then here the second number is 24. So if you notice here, we've got 24 here and we've got 24 here, so meaning that both numbers can actually go into 24 and without leaving a reminder. So meaning that if we're to simplify this, we're going to use 24 as the lowest common factor, and the second one for this one will actually be 32, and then from 32 it's going to say 40, and from 40 we're gonna have what we call 48. So for this one we're gonna just have 48, I think, from this. So this is the second common factor within this, but the lowest common factor that we can actually use is actually 24 for these two values, which we can also calculate it through the line method. So this method that we're using, we call it the line method of calculating the lowest common multiple factor. And when do we get to apply this lowest common multiple factor? So we get to apply it when we're doing fractions. That's where most of the time. So it allows us to simplify fraction very fast, because once you understand the prime factor and the lowest common multiple factor, you can actually simplify both of the fraction and add them together if you are adding fractions. So here we're looking at the common factor for 15, 12, and 6. So for 15, we know that 2 cannot go into this. So 3 can actually go. So we start with 3 and say 15 divided by 3 is going to give us 5. So this is the first one. And then we move forward and go and say it can no longer go. 3 can no longer go. So therefore we're going to say 5 divided by 5, giving us 1, which is the last answer have to be 1. So therefore our factors within this is 3 and 5. And then for 12 we have got 2, which can actually go into this, so therefore we start with 2. So 12 divided by 2 giving us 6, and 2 can still go into 6, so therefore we still use it, and therefore say 6 divided by 2. So we used our first 2 again, and we still use 2 and the second answer again, and therefore the last answer 2 cannot go into, so we use the same value, which is 3, to say 3 divided by 3 giving us 1, so therefore we've got 3. And then we move towards the last value, which is 6, to say let's find the prime factors within 6. So we've got 6 divided by 2 can actually give us a value which is a whole number, so we use 2 as the first prime factor. There it's there. And then we move forward and go and say 6 divide, so we've got 3 here, so we're going to say 3 divided by 3 will give us 1 because 2 cannot go there, so we also use 3. So when we write this down, we have got 3 multiplied by 5 for the first one, and then the second one, which is for 12, we have got 2 here multiplied by 2, then multiplied by 3. So those are the prime factors. And for 6, we have got 2 here and we've got 3. Because we're working with 3 digits, so what we're gonna do is that we're gonna take a look in terms of numbers that are actually repeating within these fractions. So for the first one, we've got this, we're gonna crash 1, and then again we move to the second part to see what is we have on the second part. So because we are looking in terms of 3 numbers, we're gonna delete only one number that have been repeated more than once on the first section. So this one, if you take a look into this one, so we've got 3 here and we've got another 3 here, which was the last section. So meaning that this one will actually get to repeat, so we're going to cancel 1. So meaning that we cancel 1, the first one, and for this one, because they are going together as the last digits, so therefore we're going to take a look into this. So this one doesn't have its own player, so it's going to stick within, because it's falling within alone as the middle common factor within all the numbers that we're playing around. Because these one are the last, so we play all of them together as the last digits. So we'll take a look into them together. So meaning that we are left with 3, we are left with 5, we are left with the 2, and then we're left with the last 2 as well. So meaning that we've got 3 times 5 times 2 times 2 giving us 60. So if we're to do a multiple of all of these numbers, we'll get that the lowest common factor that both of these numbers can go into and not leave a remainder is actually 60. So if we use this and go and say we've got 12, it's 15, 12, and 6. So 6 plus 6 is the same as saying 6 plus 6 is the same as saying 6 times 2, which is for the first. Okay, yeah, I made a mistake. It's supposed to be saying equals to. Okay, the other one is not yet giving us what we want. So this is the other way to find the quickest lowest common multiple factor. So what we go and perform is that we go and say the lowest for 15. Okay, we've got 15, 12, and 6. They cannot all go into each other. So the first line we've got 30, 24, and 12. Okay, 6 can go into 12, so but 15 cannot go. So meaning that this cannot be a lowest common factor. And then 45, 36, 18, it's not repeating on both of them. We've got 60 here and we've got 48, we've got 24. Okay, now we've got 24 for 2 and 6. But for 6 and 2, the lowest common factor will actually be 12. So the lowest common factor will actually be 12 because we've got 12 already here and we've got 6 here. And then again, we've got another second one, which is 24. So the lowest common factor that we can use for 12 and 6 is 24, which is not 12. So therefore we move forward since we're also looking for now one that can 15 go into. So I've got 75, 60, and I've got 30. So already now here I've got 15 and 12, which can go to 30. So therefore we can continue to move forward until one number repeat uh, on both of these multiplication of two of these numbers. So once you go down, you notice that 60 is the first number that repeats on both of them. So meaning that 60 is the lowest common multiplier, meaning that if you go and say 60 divided by 15, it will give you a whole number. If you go and say 60 divided by 12, it will still give you a whole number. If you go and say 60 divided by 6, it will still give you a whole number. So 60 becomes what we call the lowest common multiple factor. So I'm just gonna give you an activity that you'll have to perform. But before you perform that, let's see how many. Okay. I also check time so that we see that time is on our side. So let's start with the first one. Here's an activity. Calculate the lowest common multiplier between 15, 25, and 45. And then the one for 16, 15, and 18. So what I'm going to do is that I'm going to split these to you guys. So let's me split it into three. So Ipeling, please do number one. Neo, please do number two. Sandisile, please do number three. I'm going to give you guys 4 minutes to actually do this, meaning that by 2 o'clock you should be done with the calculation. So please perform this and then give me the final figures after 4 minutes. Calculate the lowest common factor for 15, 25, 45, and the lowest common factor for 16, 15, and 18, and the lowest common factor for 30, 70, and 50. So first one is for Ipeleng, and then second one is for Neo, third one is for Sandisile. 4 minutes, and then we do the solution. Okay, 3 minutes remaining. Two minutes and some seconds remaining. Okay, are you guys done? Or you are still continuing? You want the full time? Okay, almost 1 minute is remaining. Okay, few seconds remaining. And time is up. Let's start with Ipeling. So what did you get for number 1, 15, 25, 45? What is the common factor that you get? Ipeling or Ipiling? Ipiling, are you around? Ipiling or Ipeling? Okay, no one is there. Let's move to Neo. The second one. Common factor for 16, 15 and 18. Lowest common factor. How much did you get? Guys, all your mix are available. You can just unmute. Neo. Sandisile. The third one.
Say I got 1050.
You got how much?
Say I'm just gonna take a guess between 1500 or 1050. I'm not sure.
1000. Did you calculate it?
Can I?
No, the question was I gave you 4 minutes to calculate it. So how much did you get? What is the common factor, lowest common factor? Where both 30, 70 and 50 can go into and do not leave any remainder.
I got 1050.
1050.
Yeah.
Okay, let's check Neo and I see there is a comment. You make it available, Ipeling. I see that you're struggling to unmute. So let's take a look in terms of this. The first one, 15, 25, 45. So this is how you are going to do it. For 15, so they started with the 16, 15 and 18, which is for Neo. So what's going to happen is that we're going to say the first common factor is 2 and then the last common factor is 3. So say 6 divided by 2, which is 3, and therefore we can say 3 divided by 3, giving us 1. So that is 2 to 3. And then we move towards 15. 15, we're going to start with 3, which is the lowest one that can be used. So therefore, we're going to say 15 divided by 3, we're going to give us 5, and therefore 5 divided by 5, giving us 1. So the common factors used here, or the prime factors used, are 3 and 15. And then for 18, we have got 18 divided by 2, which 2 can still go and get us 9. And then 9, 2 cannot go, so then we're going to use the second common factor, which is 3, prime factor, which is 3. 9 divided by 3, that gives us 3. And then 3 divided by 3, that gives us 3. So 3 have been used 2 times on this one. So since we are done with all the prime factors, so what we're going to do, we're going to check the repeats. So we've got 2 and 3 being repeating, and therefore on the first one we're going to crash out 2, and on the second one we're going to crash out 3. So you can crash the first 3 and the last 3 and then leave the one in the middle. So here they just crash because already there is a repeat of those numbers, so meaning that we have got if we're to crash it properly, so we're going to say this is a repeat and here it's repeating, so let's crash this one out, and then we're going to move forward and say, okay, we have got this part here and this part here and this part and this part here, so let's just crash one out. So either we crash this one out or we crash this last one out or this one here out. So therefore we're only left with the remaining 3, so meaning that we'll be left with 2 times 3 times 5 and times 3, giving us 90. So meaning that the lowest common factor for 6, 15, 18 is actually 90, which we can actually get to come this side and put that. So I've got 15 here. We have got so it's 18 the other one. So if I change this to 18, so we can actually get to look for the common factor. So here it's now 18. So if it's 18, we try to look here. You will notice that okay, this one will need to be expanded until we find something similar. So 60 on these two is there, but and then we also have got 30 on these two, but we do not have them on 18. So meaning that it cannot, both of the two cannot be the lowest common factor. But if we take a look, we've got 90 here, we've got 90 here, and we've got 90 here, which is the smallest number repeating before any other number. So therefore 90 becomes our what? Lowest common factor. So this is another method that you can actually get to use. And then when we move to the 30, 70, 50, which was for Sunday Sile. So the answer is 1050, which you are still correct. So under this one, you can go on to say, okay, 2 can actually go into this. So therefore, we're going to start by 2. 30 divided by 2 will give us 15, and 2 cannot go into 15. So the second is 3. 3 can actually go into 15. So we're going to say 15 divided by 3, giving us 5. And 3 cannot go into 5. So we choose the third one, which is 5. So therefore, we're going to have the factors being 2, 2, 3, and 5 for 30. And then for 70, we're going to still have 2. And then we're going to have 5 for 35 divided by 5, giving us 7. And therefore, for us to, this one does 2, 3, 5 cannot go. Therefore, 7 can go. So that will be 7 divided by 7, giving us what? 1. And then for the last one, it's 50. 50 divided by 2, it's going to give us 25, and 25 divided by 25 cannot be divided by 3, so we're going to jump 3 and move to 5. Therefore, 25 divided by 5, giving us 5, and 5 can only be divisible by 5 again. So meaning that we are going to say 5 divided by 5, giving us 1. And therefore, this will actually give us the following. So therefore, we have to cross 1 out here. So we can just go and say, since we've got under this 50 and we have got 2 and 5 and 2 and 5, so meaning that it's a repeat. So here we can cross this one out, and once we cross one out, then we're gonna move forward and say what was the max. So here we've got 5, so we can cross 1 5 out, and then we're gonna go and say the last digits. Again, we've got another 5, so meaning that we're gonna cross another 5 out. So meaning that we're left with 2 times 3 2 times 3 times 2 repeated 3 times on this one, and then times 5 times 7 times 5. So we've got the following 1050. So when you multiply this together, so if we're using the other method, which is 30, we've got 30, we've got 70, and we've got 50. So here I'm just gonna say it's 30. So this will actually be a very long number. This will actually be a very long calculation for you to be able to reach to 1050. So that other method, it becomes much simpler when you're working with smaller numbers. And then we've got for this one, for 70, and I say 70, and then we're just gonna drag this down and add 70 until we find a common number. And then again for this one, I'm gonna add 50, adding each other, and then we're gonna continue until we get each other. So based on this, we can start to take a look to say what is the most repetitive number, which is the lowest number that repeat on both sides. So while you're going down, you'll see that here we've got 150, we've got 150, but here we don't have 150, we've got 140. So meaning that the lowest common factor for 30 and 50 could actually be 150. And then we move downwards, as we are moving down, you can see the numbers and here we've got 300. So the second lowest common factor for these two, 30 and 50, could actually be 300. And then you're gonna go down again, just going down, keep going down, keep going down until you find one that is on both. So the lowest that is on both here, we've got 1050 here and 1050 here, as well as 1050 on the other one. So meaning that 1050 becomes a lowest common factor for the third one. And then the last one, which is just okay, the last one is actually a bit different from what we did in terms of what we required. So it's actually different. It's supposed to be, we did this one, we did this one, we didn't do this one. So let's do for 15, 25, 45. I think we already covered that on the lesson. So yeah, I think it's already sorted. So this is the one for 3, 7, and 5. So the lowest common factor for 3, 7, and 5 will be 3 divided by 3, giving us 3, 7 divided by 7, giving us 7, 5 divided by 7, giving us 5 divided by 5, giving us 1. So when we do this one, we start by taking a look into the prime factors. We've got 1 and 2, they cannot go, so therefore we're going to use 3. We don't just go and say divide by 7. So under this one, which is 7, you're going to go and say, can 2 divide this? No, it cannot. And then can 3 divide this? No, it cannot. Can 5 divide this? No, it cannot. Then can 7 divide this? Yes, 7 divided by 7 is 1. So that becomes the prime factor. So the prime factor for all the prime factor numbers are their own numbers. So if we have got 2 and you are trying to find a prime factor for 2, that will actually be 2, because 1, if it goes to 2, it will give us 2, meaning that we cannot use 1 because that number is going to still be the same number. So therefore we're going to say 2 divided by 2, giving us 1. So 2 becomes the prime factor for 2. Unlike 4, where 4 we can actually go and say 4 divided by 2 and give us 2, and therefore 2 divided by 2 give us 1. So therefore the prime factor for 4 is 2 times 2. And then if we go and say 4 divided by 4, we're gonna get 1, but will it work with the other number when we say looking for prime factors? So prime factors have to be all the same for all the numbers that we're using. Out of it fall within 1, 2, 5, 1, 2, 3, 5, 7, and 9. So it have to be falling within those numbers. And then we have got converting the following mixed fraction into improper fraction. So we've got the first one and the second one, so you have to apply the med, and this one from improper fraction to mixed fraction. So within the remaining time, I'll just do it with you guys. So what we're gonna do is that on the first one, converting mixed fraction into proper fraction into improper fraction, we said we use what we call med. We use what we call med. Meaning that when we're converting a mixed fraction into proper fraction, we're gonna say the whole number multiplied by the denominator first, which is the m, that's what the m stand for, multiply 6 multiplied by 1, that will give us 6, and then we add the number to the numerator, which is 6 plus 5, giving us 11 over 6. So that is the answer for this one. So if you go and say 11 over 6 on your calculator, you will still get the same answer as 1 over 5 over 6. If you have got a scientific calculator have got this other function called SD to convert decimal into fraction. If they have got a fraction, it will give you this final figure here, or this 11 over 6. And then for number 2, we're gonna go and say this, and then this will then add with the answer that we get. 11 multiplied by 3, that's gonna give us 33. And then once we get 33, we say 33 plus 7, that's gonna give us 38 over 11. So this will be the improper fraction. And for this one, we do the opposite. We're going to say how many times does 22 goes in, how many times does 8 goes into 22. So you'll still use your calculator for that, or if you don't want to use a calculator, just say 8 plus 8. 8 plus 8, that's 16. And then you said plus 8, 16 plus 8, that's 24, meaning that that's more now, meaning that 8 can only go 2 times on 22. So meaning that what is the remainder of the number? So therefore you can say, if it's 16, then you can go and say I see that there is a comment. It's 40 over 11. It's actually 38. Oh, sorry about that. Yes, it is 40 out of 11. My mistake. I'm saying 30 instead of, I'm saying 31 instead of 33. So sorry about that. Thank you for recorrecting me. So it's actually 40 over 11. In my head, I'm saying 31 instead of 33. So thank you very much, Sandy Sile, for the correction. And then here we've got 22 divided by 8. So if you said 8 plus 8, I was saying it's 16. And therefore you're going to say 22 minus 16. That will give you 6. So meaning that it is 2. It goes 2 times, and therefore it leaves 6. It's going to leave 6 over 8. So this is the improper fraction for 22 over 8. And then when you go to this one, 17 over 19. 17 over 9, so you're gonna say 9 plus 9, that's actually 18. So meaning that 9 can only go one time, because 9 plus 9, if it's 2 times, therefore it's above 17, so it cannot go 2 times on 17. So that's already 1. And therefore what is the remainder of the value from this equation? So we've got 9, so meaning that's gonna be 17 minus 9. So 17 minus 9, that will give us 8. So meaning that the remaining value is 8. So another method to actually get to calculate this was to actually go and say, okay, based on this value, so this is just something I'm just gonna do, is to go and say, okay, based on this value, if say 9 plus 9, it's gonna give us 18. And here we've got 17. So it means that we are short by 1, meaning that if we're short by 1, it means that that value is 8, because if we say 9 plus 8 is going to give us 17. So that's another methodology without having to say 17 minus 9. So that's another method you get to use. For example, on the above one, it says 22 divided by 8. If we said 8 plus 8, that's actually giving you 16. And if you said plus 8, that's 24. And 24 to 22, the difference is the value of 2. So meaning that 8 minus 2 is actually how much? 6. So meaning that you have the value of 6. For the bottom one, you say 9 plus 9, it's 18. And the difference between these, it's actually what? 1. So you can go and say 9 minus 1 giving you 8. So therefore the value of remainder is 8. So it goes 1, and whatever remainder will be 8 over 9. So that is the way to convert fraction into improper fraction, and proper mixed fraction into improper fraction. So any question? Any question, guys? Do you have any question? If you don't have any question, this is what's happening. Actually, your summative formative assessment is out of 100, and it's going to be written for 3 hours on campus on the 14th of April. So that is the time that you're going to be writing. It's going to be Friday on the 14th of April. The time, I've not yet received the time and the venue. So just know that you're going to be writing for 3 hours. There was a error in terms of the briefing. You are supposed to, it was supposed to say 3 hours instead of 2, which I was questioning it as well with you guys. So yes, it is 3 hours. You'll be writing this for 3 hours. The paper for 3 hours, 400 marks. So that is it from my side. If there is no question, please enjoy your weekend nicely, and then we'll meet next week when we do lesson 7 and 8. Thank you very much.